We are continuing on with probability. We have discussed what is probability. So can you repeat it from last lesson if you remember? What's probability?
The chance of something happening.
Chance of something happening. So give me an example of somewhere you'd use the word probability. Yeah?
The probability of rolling a 2 on a dice is 1 out of 6.
Yep, so the probability of rolling a 2 on a die is 2 out of 6. 1 out of 6. It's not 2 out of 6, 1 out of 6. Now, does that mean that if I roll a die 6 times that I'll definitely get the number 2 once? No. Then what does probability tell us? Like, why do we even need it then? Okay, what does it tell us? Yeah, the chance. So how likely is something to happen? Or how unlikely is something to happen? So for example, if I have 2 dice, I have a normal 6-sided die and I have a 20-sided die. Have you ever seen a 20-sided die?
Yes.
Yeah, great. Now, so the one die has numbers 1 to 6, pens down as on the board. The other die has numbers 1 to 20. On which die it's more likely that I'll get number 2?
The first die?
The 6-sided die, isn't it? So what's the chance that I'll roll the number 2 on the first die? 1 out of 6. What's the chance I'll roll number 2 on the second die? 1 out of 20. But does that mean if I roll them that I'll definitely get number 2 on the first one? No. Might actually get it on the second one, on the first go. Might not get it on the first one, or maybe even trying 10 times. So probability tells us how likely an event is to happen, but that doesn't mean it will happen or definitely not happen. Another example is winning the lottery. Are we very likely to win the lottery? No. Unlikely, right? However, does that mean we'll never win it? No. You have to be in it to win it, don't you? Yeah. Yes? So it doesn't matter how low the odds are, the event can still happen, or how likely an outcome is, it can still not happen. For example, let's say cricket favourites. The World Cup's coming, the only sport I care about. Who's the favourite to win?
India?
Yeah, India, so it's my team. The favourites to win. But does that mean they'll win it? Probably not. So, however, they're likely. The probability is that they are very likely to win the World Cup, but it does not mean that they'll definitely win. Does that make sense? So, probability is the chance of something happening. It tells us how likely or unlikely an event is to happen. We use the words from a scale of 0 to 1. Something that has a probability of 1. We put our screens down now. I should not have to repeat myself that many times. Something that has a probability of 1 is certain. Give me an example of an event that is certain, a sensible one.
Tomorrow's Thursday.
Tomorrow's Thursday. What day is it today?
Wednesday.
So are we certain tomorrow will be Thursday? Yes. That's a very good example of something that is certain. Now, you need to give me an example of an event that has 0 chance of happening. So it's impossible.
Tomorrow's going to be Saturday.
Well done. Tomorrow is going to be Saturday. What are the chances? 0. It's impossible. Do we understand that? Okay, now if I flip a coin, what is the chance that I'll get a head? It's even chance, isn't it? Because there's 2 choices, either head can come up or tail. So, and they're both equally likely, so that's even chance. So probability, when we write it in terms of numbers, goes from the scale of 0 to 1. It cannot exceed 1. Are we clear on that? So 1 is when it's certain. 0 is when it's impossible. So 0.5 is when it is even chance. Okay? We can use percentages as well, or fractions, to represent probability as well. So 3 ways. Numbers, 0 to 1. In numbers you can use decimals or fractions or whole numbers. If it's a whole number, you can also use percentages. Happy with that? Now, in terms of words, anything that's less than even chance is unlikely. So if it's just less than 0.5, it's somewhat unlikely. If it's close to 0, it's highly unlikely. Right? So if I have a die that's a 100-sided die, let's say we make one up, what's the probability of getting the number 1? It's unlikely, isn't it? Very unlikely, I'd say. Yes? If I have a deck of cards, what's the chance that I'll get a red card out?
1 out of 4. Half.
Isn't it an even chance? Half? Yes? I need in terms of words. Give me an example of something that's highly likely. Yes.
Homework tomorrow.
Oh yeah, maths homework. Will I give you maths homework? I'd say that's certain.
Yeah.
Yeah, that's not highly likely, that's certain. Do you get homework tonight? Yes. Yep.
Highly likely that someone won't injure themselves outside.
Yes, let's hope that doesn't happen. I'd like that to be unlikely. Yes.
It's highly likely that there will be no rain today.
Yes, it's very likely that it won't rain today. That's good because we've checked the weather forecast. It's going to be sunny and nice. So it's very unlikely that it'll rain today. But it's Melbourne. Who knows?
We have 4 seasons in 30 minutes.
Exactly. So yeah, I wouldn't put my money on that one. So do we understand? Yes. So there's, in terms of words, we use the words like impossible or certain only when it's 0 and 1. Even chance only when it's 0.5. As we go towards the 0, the chances are decreasing. As we go towards the 1, the chances are increasing. But unless it's certain, does not matter how likely you are to, have that event. Does that mean it'll happen? No. So probability does not tell us whether it'll happen or not, unless it's certain and impossible. Anything in between, it only tells us how likely it is to happen. Does that make sense? All right, pens down. Sitting up. Now, sample space. So when we talk about an event is something that's going to happen. For example, flipping a coin. Is that an event? Yes. Rolling a die. Is that an event? Yes. Raining or not raining tonight? Event? Now, every event has a list of outcomes that are possible. So writing all those lists is the sample space. We did talk about it yesterday, didn't we? So sample space is writing the list of all possible outcomes, because when we have a list of all outcomes, we can then work out how likely a particular outcome is. Yes? Now, we always use curly brackets. I mentioned it yesterday why we use a curly bracket, and I'll talk about it again when we do part B. So the first one, flipping a coin. So a normal two-sided coin. First thing, it's the sample space, so the curly brackets. Then, write all possible outcomes. So what are the 2 possible outcomes?
Heads and tails.
Heads and tails. You can just write H and T, or you can write heads and tails. Is that clear? Now, rolling a die, a normal 6-sided die. What are the outcomes?
1, 2, 3, 4, 5, and 6.
Yeah. Now, when we use these curly brackets, it only indicates that the numbers that I've written there are included as outcomes. Are there any other numbers in between 1 and 6?
Yes.
Plenty. 1.1, 1.2, 2.1, 2.2. There's infinite numbers, right? But when we put curly brackets, we're not doing numbers 1 to 6. We're only dealing with number 1, number 2, number 3, number 4, number 5, and number 6. Only the numbers written inside the curly brackets are the possible outcomes. Are we clear with that? So it's very important to use the correct set of brackets while writing the sample space. You use another bracket, you use the square bracket, or you use the round bracket, that's wrong. We do not use them for sample space. Is that clear? Now, everyone knows what's the maximum probability of an event?
1.
1. What's the minimum probability? What's halfway? Does probability tells us definitely if an event will happen or not? Not necessarily. The only case when it's definite is if it's 0 or 1. Everything else in between is just a chance. Right? Any questions? Great.